Hello everyone, this is Karthikeyan. I'm a candidate master on Code Forces, 5-star on CodeChef, ICPC Kanpur Mathura Regionals 2020 rank 27 and global rank 251 in Google Kickstart Round Day 2021. And today I am going to discuss the problem chef and ground. The problem was asked in October Challenge 2014. The difficulty level of the problem is Cakewalk, the prerequisites are ad hoc and basic maths, and the number of submissions that this problem got during the contest was 6,223. Let's move on to the problem statement. So today chef wants to clean his garden. There are n columns of ground. So basically there are n columns in the garden of chef. Each column has its height. There is a height of every column. Chef can choose any column and increase its height by 1 using 1 cube of ground. The height of a column can be increased by 1 by using 1 cube of ground. Chef wants to spend exactly m cubes. Exactly m cubes would be spent. Can he make this in such a way that the height of all columns become equal? So we have to tell that whether there is a way possible such that after spending exactly m cubes, the height of all the columns, all the n columns become equal. Now in every test case, there are two integers n and m, where n denotes the number of columns and m denotes the number of cubes we are required to spend. After that, there are n space separated integers where a of I denotes the height of the ith column. Let's move on to a bit of explanation. Okay. Now, since we want the height of all the columns to be same, okay, so we can definitely say that every column a of I first of all needs to attain the maximum height or the maximum of a of j such that j is from 1 to n. So every column a of I must need to acquire the maximum height among all the n columns. So every column first of all must reach the maxima. If this is the maxima and these are the columns, then every column must acquire the same height, and after that the remaining number of cubes must be spent equally among the remaining columns, among all the n columns. Okay, so let's discuss the first test case, which is 3, 3, 4, 2 and 1. In this test case we are having 7 cubes to spend. Okay, let's see how we would spend these cubes. First of all, I would make this to 4 and using 1 cube. I would also make this to 4 using 1 cube because 4 is the maxima. This would remain 4, no cube is used. I would increase it to 4 using 1 cube and using 2 cubes. Okay. Now I would increase it to 4 using 3 cubes. Yes. So yes, in this test case, it is possible. All the columns got a height of 4 and it is possible that all the columns have the same height. Let's solve the second test case, which is 3, 3, 4, 2, 1. We are having 6 cubes, okay? The maxima is 4. Now, I would increase it to 4 by using a single cube. I would increase this 3 to 4 using a single cube. I would not touch it because it is the maxima. I would increase it to what? To 4 using 2 cubes. Now I would like to increase it to 4 using 3 cubes, but I am having only 2 cubes left. So the answer for this test case would be no. Now the third test case, which is 3, 3, 4, 2 and 1. The number of cubes are 8. Now the maximum number is 4. I would like to increase 3 to 4 using 1 cube. I would like to increase this 3 to 4 using 1 cube. This 4 would remain same. This 2 would be increased to 4 using 1 cube or using 2 cubes. Yeah, 1 cube to 3 and then another cube to 4. This would be increased to 4 using 3 cubes. So only 1 cube is left. Now, can this 1 cube left be equally divided among 5 numbers? For that to be possible, 1 modulo 5 has to be equal 0. But it is not equal to 0. So it's not possible. So what I'm trying to say is basically, first of all, m has to be greater than or equal to the summation of what? If x denotes the maximum number of the array, x denotes the maximum of the array, minus a of I, because every element I must first of all become the maximum element, or basically every element I must be same. So m has to be greater than or equal to the summation of this, and m minus, after this every particular column is having the same height, m minus the number of coins left after this, or the number of cubes left after this, should be equally divided among the n blocks. So this should be perfectly divisible by n. So this is the case we require to solve this problem. Now let's move on to the code. Here is my code. And I am coding in C because there is not an option to submit the code in C++. Here T denotes the number of test cases, N denotes the number of columns, M denotes the amount of cubes we have to spend. I take N and M as input. Here A is the array, Mx denotes the maxima of the array, and sum denotes the sum of elements of the array. Now for I just iterate and I just take the input of the array, and after this what I do, okay, I think that I should have written n plus 1 here because I am using 1 based indexing. Okay, so I just iterate and take the input of the array, the ith element of the array. I add the ith element of the array in the sum, and if the ith element of the array is greater than the maximum element, then I update the maximum. Now first of all, every element needs to be the maxima. So what can we say? We can say that x minus a of 1 plus x minus a of 2 plus x minus a of 3 plus x minus a of 4 and so on. So x has been taken how many number of times? N number of times. So mx into n. And minus a of 1, minus a of 2, minus a of 3, minus a of 4 till minus a of n. So it is negation of the sum. This is the number of operations we are required to perform. After performing this many number of operations, the number of operations which would be left would be m minus op. Now, if the number of operations that are left is greater than or equal to 0, this means that we didn't run out of operations while making the height of all the buildings equal to the maximum height. If this condition is satisfied, then it means that we were having enough number of operations to make the height of each and every building equal to the maximum height. And after this, the operations which are left can be equally divided among the n buildings. So if this is true, then op underscore left modulo n equal 0. I would print a yes, elsewise I would print a no. So let's try submitting the solution. You can see that the code got accepted. So if you have any doubt regarding the approach, you can ask in the comment section. And thank you for watching the video.